The spoke-type Cutterhead, which is primarily used for soils and very soft ground, is as wide open as possible. The other type of Cutterheads that are used on EPBs are fairly closed Cutterheads. These are the types that are used in mixed ground conditions. In mixed ground conditions, there is possibility of existence of boulders, and there's only a certain size of boulders that could be handled and ingested by the ribbon screw conveyors, and for that reason, we have to limit the size of the boulders that can enter the muck chamber and eventually into the screw conveyor by controlling the opening size of the Cutterhead. So this one is a fairly closed design of the Cutterhead, and the one on the left is a fairly open design of the Cutterhead. And they both have their own applications. Obviously, we can put various different cutters, install various cutters on the Cutterheads. For Cutterheads that are designed for mixed ground conditions, we will install, or we do install, disc cutters, single disc cutters on the face and gauge areas, and double twin disc cutters in the center area to minimize the space required for having these disc cutters installed at a proper spacing. And for pure soft ground applications, we have scrapers and knife edge bits, and this type of these cutters that are shown, the type of cutters that are shown on the right-hand side. Obviously, in mixed ground conditions, we install a combination of disc cutters and soft ground tools on the Cutterhead. One interesting thing that we're doing at the Robbins Company is that these soft ground tools that we install on the Cutterheads, we have two sets of them. One set is installed on the Cutterhead slightly prouder than the second set. In other words, the standoff, the distance from the tip of the cutter bit to the face of the Cutterhead on the first set is slightly larger than the second set. The advantage of this kind of installation is that the first set, which is standing prouder than the second set, obviously wears faster and wears first. And these two graphs is an indication of the wear pattern of those type of installations. The first cutter set, which is shown in blue, let me turn my pointer on. This is the wear pattern of the first cutter set, and let's say that the first cutter set can actually last for 800 meters of tunnel excavation. At that point, these are totally worn out, but the second set, which is sitting slightly below the first set, still have some life left in them, and they continue. The machine can continue boring and excavating for another, let's say, 400 meters, which is 50% of the first set, and that prolongs the productive life of the cutters before the intervention. Again, smooth flow of the material around the Cutterhead is a very important criteria for design of the Cutterheads. Large Cutterhead opening ratios allows for material to smoothly flow from the face to the inside of the pressure chamber or the muck chamber. And another important aspect of Cutterhead design is installation of mixing bars strategically to constantly agitate and mix this, the muck that has entered the pressure chamber, to homogenize it and to make it flow smoother so it can flow down to the intake of the screw conveyor and naturally feed into a screw conveyor. mixing bars are very important because if they are not placed correctly, they create areas of stagnant muck, which create problems like high abrasion and lack of proper flow of material into the screw conveyor. The high abrasion on the Cutterhead and the cutting tools can be caused by several factors. Obviously, the first one is abrasive ground material. Then, secondly, it's the design of the Cutterhead. If inadequate wear protection measures are taken, then the Cutterhead, the base structure of the Cutterhead wears fast. And if there are high loads on the Cutterhead, if the pressure on the face is high, which results in high loads on the Cutterhead, that results in increase in Cutterhead abrasion. The job is to minimize and to control Cutterhead abrasion. We install several wear protection bits and cutters in multiple directions around the periphery and on the rim of the Cutterhead structure. These are trim bits or drag bits, which are shown here, and another type of trim bits, knife edge bits, which are mounted to the rim of the Cutterhead. This structure is basically the outer surface of the Cutterhead, the periphery of the Cutterhead. And then there are side protection bits, which are these bars here impregnated with carbide material, very hard and very resistant. And these are mounted to the rim of the Cutterhead structure at a certain distance and all the way around to protect the base plate of the Cutterhead from abrasion. And the last line of defense is the application of hard-facing beads immediately on the plate that goes around the Cutterhead. So question number 4 is up, and we are ready for the next question from Desiree.
Yeah, this one is 2 parts. What are the most difficult ground conditions for an EPB, and are there certain ground conditions where EPBs should not be used?
Well, I'll ask Mr. Kanda to answer this question, if you like to. I can take it if you want. Do you want me to take it? Yes. The experience has shown that the most difficult ground conditions for EPB application are most challenging. I wouldn't say it is difficult and challenging, but it's not impossible to excavate that kind of ground conditions. It's a mixed ground condition, whereas the lower half of the face is a very hard rock, like granite, and the upper half of the face is soil. We typically see this kind of formations in Singapore. We have seen them in Singapore, and we have been able to excavate that kind of material, but it was challenging. So I guess that is the answer to the question. Is that fun? Okay, I think we are ready to go to the next slide. Now that you're done with the Cutterheads, we're going to talk about the next very important component on EPBs, and that is the screw conveyors. As you see on the slide, we believe that the screw conveyor is the answer to many common problems that happen in soft ground tunneling. Here, I will show you a video that basically explains the operation of screw conveyors As it was explained at the beginning of the presentation, you will hear the sound on your PC speakers. And if you don't see the video, this presentation is being recorded and it will be available online for you to go back to in future and see the video in future.
Pressure differential between the chamber and the screw conveyor then draws the muck into the screw conveyor. As this happens, the muck's pressure is reduced from ground pressure to atmospheric pressure. The depth of the tunnel, the ground material, and the water level above the tunnel determine the ground pressure. In the case of lower ground pressure, only one screw conveyor may be needed. For projects with high ground pressure, Robbins installs two screw conveyors in order to bring down the pressure smoothly. After passing through the screw conveyors, the muck can be transferred to an open belt conveyor and then removed from the tunnel by muck cars or a conveyor system.
I guess we are ready to move on with the rest of the presentation. As I said in an earlier slide, Cutterhead loading is a contributor to the abrasion of the Cutterhead. So to minimize and to mitigate the high loads on the Cutterhead, the screw conveyors should be used effectively, and they should have the correct capacity. In some cases, especially in mixed ground conditions, we should have a ribbon type screw that allows removal of boulders from the face. So screw conveyor actually contributes to mitigation of wear on the Cutterhead by optimizing the material flow from the pressure chamber. This is a drawing of an arrangement with two screw conveyors. This is screw conveyor number 1, screw conveyor number 2. In high face pressure applications, it is sometimes advisable to have two sets of screws, because each one of these screws can, as we said earlier, can take care of about 3 to 3.5 bar of pressure. So we install two of them in series, so the machine can handle face pressures of up to about 7 bar. But some contractors and some machine operators don't like the added complication of having the second screw. In such cases, we still can operate the machine in ground pressures higher than 3.5 bar by sequentially closing and opening the gates on the first screw and pushing the material up the screw to the discharge point. But obviously, in that case, the advance rate of the machine is slowed down to allow us to do the sequential operation of the gates of the screw conveyor. This is an interesting table. It basically covers several combinations of shaft screws and ribbon screws and their properties and characteristics. For example, case number 1, when you have only one shaft screw, it doesn't have any it's not very good at all in handling boulders, but it has very good water tightness characteristics. If we have, let's say, two ribbon screws, ribbon screws are designed to handle boulders. They have excellent boulder handling properties, and they have a very good water tightness and pressure holding properties. And you can see there's different combinations of these